This is a recording for graph transformation, tutorial 6, question 7. Okay, so for this question, you are given the graph of y equals to fx, as shown in the diagram, and you are asked to sketch two graphs, the gradient graphs, okay, f prime x, as well as the reciprocal graph 1 over fx. Okay, so I'll go through them one at a time. If you really know how to do this, you can scroll towards the end for the final answer for checking. Right? Okay, so just take note that this graph has a minimum point at A, and A small letter is a positive number. Take note as well that there are some additional information given in this question. They specifically give you the gradients at point B and C. So we will see how it will be used later on. Okay, so we'll first sketch the gradient graphs. Okay. So I got 3 steps for you. Number 1 is actually to detect stationary points. All right, so what happened is that for stationary points, it's very clear the gradient is 0. So I'll mark up in green here, the stationary point is actually point A. So because this guy is a stationary point, A will come here. Okay, so no other stationary points. All right, for gradient graphs, there are no change to vertical asymptotes. Okay, so I don't really include this as a point to take note, but just take note that vertical asymptotes are unchanged. Okay, so I call it 0.0. Later I will cover about the horizontal asymptote. Okay, so just remember vertical asymptotes unchanged. Step 2, okay, you just look at the gradient and see if it's a positive gradient or a negative gradient. Okay, positive gradients are gradients that are sloping upwards, and negative gradients are those that slope downwards. So for example, if you look here, if you have your ruler, you move from left to right, you can see that this side, the gradients are all sloping downwards. So I can say safely that here, the gradient will be negative in value. On the other hand, this side, you can see that the gradients are sloping upwards, going to be positive in value. Okay, and this side here also sloping upwards, also positive in value. Okay, so what I'm going to do is I'm just going to shade this area just to tell myself that, hey, I'm not going to draw anything here because I'm drawing gradient graphs. I know the gradient at this point, okay, this region is negative, so it should appear here. Likewise, I'm just going to shade this region away, okay, just to tell myself, hey, don't draw anything here. My gradients for this side are going to be positive. Last step, look at your gradient and ask yourself if it's increasing or decreasing. Okay, so what do I mean by that? So if you look at the gradient here, you can see that this gradient is a very large negative number. Okay, and you can see that it becomes the negative number, okay, approaches 0. It becomes less negative, so to speak, right? So what happens actually is that your gradient starts from a very large negative number, something like that, right? Assume that this number is a very large negative number, and then it actually gets smaller, okay, towards 0. And then coming after that at point A, the gradient is 0. And then now here, if you look at the top curve, the gradient is starting to increase, right? Small positive number all the way to a large positive number. Okay, in fact, approaching infinity. So therefore, this one is just going to go up. not forgetting the gradient at B, right? Because the question say that gradient at B is A over here, highlighted in yellow for you. So at B, the gradient, which is the y coordinate, will be 0. Okay. So this is a small negative number. Okay, next. All right. Start from here. You can see this part here is a very large positive gradient, right? To the right of the asymptote, the gradient is a large positive number. So he's going to start from the top, and then as it's going to decrease and decrease to a horizontal, almost a horizontal line, but not a horizontal line. So it tends to 0. Okay, so that is what's happening for this side. And lastly, you just erase the red markers just to tell you not to draw on them. And there you have it, your graph of y equals to f prime x. Okay, and I hope you can see why I didn't talk about the horizontal asymptote. Okay, they are gone, all right, because you're only focusing on the gradients for gradient graph. But not forgetting, you have the gradient at C. Okay, take note, C, x value A, gradient is A. Make sure you draw your C on the same level as B because their y coordinates are the same. Okay, and we are done here. All right, so of course, erase all these crosses and all that. Yeah. Okay, now reciprocal graphs. Again, I also have 3 shortcut tips for you. Okay, of course, again, step 0, I don't really want to cover that, is the fact that horizontal asymptotes, you take reciprocal, right? Because horizontal asymptotes got to do with the y value, you see. Okay, so take reciprocal. Right, we are doing a reciprocal graph here. Okay, so y equals to a converted to y equals to negative, sorry, y equals to 1 over a as the horizontal asymptote. Okay, so all this, yeah. So let's go to things proper. Step 1 is my x-intercepts will become vertical asymptote and vice versa. What do I mean by that? Okay, let's look at it. So you see, we have an x-intercept here, point C. So what translates is that this guy will become our vertical asymptote. X equals to 2a. Vice versa. So you have a vertical asymptote here. What it translates is that it becomes a x-intercept. Step 1. Step 2. Okay, it's big, become small, and vice versa. Again, what do I mean by that? So just look here. This guy is a big value. So what's going to happen? It's going to become here. It's going to get small. All right, big value is going to get small. So this value is next to A. I'm just going to put him here. Okay, I just use green so that you can see the difference. Where else? Here. A very large negative number will become a very small negative number. So where will he go? Okay, he will go to the right of A. Okay, so I just put some reference for you. Okay, this is what happened, right? The vertical asymptote from the original graph become the x-intercept. This is what happened. Okay. And then if you look at this point next to C, okay, so you see I try to catch all the large points and all the small points and I shift them. So this red small negative value will become a very large negative value. Okay, almost there. Last step. Maximum point will become a minimum point and vice versa. So where is the maximum point here? Sorry, this one is a minimum point. So A will now become a maximum point, coordinates 1 over 2A. Take note, 1 over 2A is actually smaller than 1 over A because A is a positive number. So when you draw your graph, make sure it's below the horizontal asymptote. This is A prime, negative A, 1 over 2A. Okay? And then now you can just connect the crosses. I don't know if your childhood you had this kind of games. You connect the numbers and then eventually you get some shape. Okay? So this is just to help people with poor art like me. Okay, so same thing you do here. Not forgetting what happened to B. Okay, so there's a B over here, be careful. So you take reciprocal of the value is 1 over 3A. All right. Next. Okay, now we have yet to settle this part. Okay, this one here. Okay, look at my top graph. This part here. Okay, so this is a small positive number. So what happens? It become a big positive number. Okay, there's an asymptote here. So it's just going to shift down. There's the asymptote. And there you have it. 3 quick steps for the graph of y equals to 1 over fx. For those of you who are still struggling with the concepts, the techniques in this tool, okay, give my 3 steps a quick try for the other questions and see if you can do that. All right, so that's all. The solutions are as follows. And thank you.